Welcome back to Geometry Classroom. Today we'll talk about properties of rhombus or rhombi. Is the plural from rhombus. We have a few objectives. First, we state the properties of rhombi, apply the properties of rhombi to find the missing angles and or sides. Now, let's define a rhombus. A rhombus, as we can see, is a quadrilateral, right? With all sides equal, right? In fact, a rhombus is a parallelogram with all sides congruent or equal. Because it's a parallelogram, a rhombus has all properties specific to a parallelogram, which means opposite sides are parallel, right? Opposite sides are parallel. Opposite sides are congruent, right? Yes, these two sides are congruent. The other two opposite sides are congruent. Then, opposite angles are congruent, right? These angles, because they are opposite, are congruent. The other two angles that are opposite are congruent. Consecutive angles are supplementary. Remember how to identify consecutive angles? If you go clockwise, right, these two angles are consecutive because they follow each other. Also, 2 and 3 are consecutive. 3 and 4, 4 and 1. If you go counterclockwise, 1 and 4 are consecutive. 4 and 3, 3 and 2, 2 and 1, and so on. Now, also, diagonals, right? Diagonals are segments that join two opposite corners, right? Diagonals bisect each other, right? They cut each other into two congruent segments. But in a rhombus, we have additional properties, right? And these properties are all four sides are congruent, as I mentioned earlier. Diagonals are perpendicular. They form a right angle between them. Diagonals bisect the opposite angles. In other words, this diagonal bisects the opposite angles, which means, in this case, 1 and 2 are congruent. 3 and 4, angles 3 and 4 are also congruent. Yeah, bisect means cut the opposite angles into two other congruent angles. Also, the small triangles are right triangles. So we have 4 right triangles inside a rhombus. Good. And also, these right triangles are congruent. Good. This being said, and knowing these properties, let's have two applications with rhombus. First, what are the measures of the numbered angles in a rhombus ABCD, given this angle? Now, we know diagonals in a rhombus, right, are perpendicular to each other, which means this angle right here is 90 degrees. In fact, all are 90 degrees. Good. And also, a diagonal bisects the opposite angles, which means this angle is the same as this angle, right? This angle also congruent to the other angle, right? Now, First, we find this angle, right? Now, to find this angle, we look at this triangle, which is a right triangle. Why? Because this angle equals 90 degrees. Good. Now, first we find this angle. Now, we know this angle, which is 58. The other one is 90. We know the sum of angle measured of a triangle, right, equals 180. So, because we don't know this angle, let's denote by x. Using the triangle angle sum theorem, we can write an equation, right? So, x plus 58 plus 90 equals 180. Now, we solve for x. First, we write x as it is. Then we add 58 and 90, which is 148, equals 180. Then, to get x, we subtract 148 on both sides. And we get x equals 32 degrees. So that's the value of x. Here is 32. But as I said, the diagonal AC bisects angle BAD, which means angle 4, this angle, right, would be the same as this angle. So angle 4 would be 32 degrees. So let's write it here. Angle 4 equals 32 degrees. Now, what's next? Angle, we can find angle 1. Angle 1 is 90 degrees, right? Because the diagonals are perpendicular each other, right? So angle 1 would be 90 degrees. And also we can find angle 3. To find angle 3, we look at this right triangle, right? Now, again, we apply the triangle angle sum theorem in this right triangle, and we can, let's say, we can denote x by y, angle 3 by y, as unknown. So, we write the equation. We say 32 degrees plus 90 degrees plus y equals 180 degrees, right? We add 32 and 90, we get 122 degrees plus y equals 180 degrees. We subtract 122 on both sides, and we get y equals 58 degrees, which is angle 3. So angle 3 equals 58 degrees. And one more practice problem. In this example, we have a rhombus PQRS with diagonals PR and SQ. We know PQ, right? PQ is the side of the rhombus equals 3x plus 8. And QR, the other side, equals 2x plus 17. Right? It says find the value of x. We know in a rhombus all sides are congruent, which means PQ and RQ are congruent. Because they are congruent, these two expressions are equal. So we can write an equation. 3x plus 8 equals 2x plus 17. Then we solve for x. We combine like terms. Because 2 is less than 3, we combine everything on the left side by subtracting 2x on both sides. So we get 3x minus 2x equals x. We bring down 8 plus 8 equals, these two cancel out, we bring down 17. Then we subtract 8 on both sides to get x alone, and we get x equals 9. Good? For now, that's all we have. We'll have another lesson regarding trapezoids next time. Thank you for watching my video.